have the desires to go back to doing a bit of mathematics, but I don't seem to get the time. Anyway, in the last few years, I should say, my ex-colleagues are on strike today, so I'm feeling a bit bad about doing this, but I didn't actually have to cross a picket line to get in here, so I think it's all right. But in my last few years at the university, I did teach probability theory, even though I knew nothing about it. That's the nature of universities. I learnt a lot giving the course. That's the best and, one of the best known probability theory is great for having sort of little paradoxes. One of the best known ones is something called the Monty problem, which I've talked about before here. But I've in the past argued with John about this, so I thought I'd argue with John in public about it. So in the Monty problem, there was a game show. I did some research in the break. Yes, Let's Make a Deal it was called. If you want to see some of the depths of American culture, I mean, we experience here the peaks of American culture, but there's this game show called Let's Make a Deal, and Monty Hall was the host, and in this show, well, the main thing seemed to be that people got incredibly extravagant prizes for not doing very much, and all the other people there liked watching them get these extravagant prizes or fail to get them. In this particular game, there were 3 doors at the back of the stage, and behind one of the doors was a car, and behind the other 2 there was a goat. And I don't have any goats here, and we don't have any cars actually. The last time I did this, I did have a model car, and so I've got 3 mugs here, and underneath one of these mugs is tonight's star prize, and the star prize is actually a voucher for a 50p hot drink at Semitone Studios.
Such a deal.
So this is the sponsored presentation. And,
it's got my interest now.
So underneath one of these mugs is this voucher, and I know, I hope, which one it is. Forgotten now. Anyway, yes, the game is, and this is the same, this is modelling the game that was in the game show. So the contestant, who in this case is John, is going to guess which mug the car is under, or rather the 50p voucher. And if he gets it right, he gets the, well, there's a bit more to it, but if in the end he gets the voucher, then he'll get it right. So would you like to guess which mug has the voucher under?
From your point of view, the one on the left.
That one?
Yeah.
Right, now there's a bit more to this game than this. This was the same as in there. So I'm actually going to help you now, because I'm going to show you that under one of these other mugs, it definitely doesn't, this has nothing in it. You've got to imagine this nothing is a goat.
Yeah, fine.
So this is not the prize. And the question now is, with that information, I'm giving you the opportunity now to change your choice of mug.
I'll stay.
You're going to stay.
I'll stay. With
So what's your argument for doing that?
My argument for doing that is that because you've already removed one of the choices, I now have 2 cups left.
Yeah.
With 2 cups left, you've got a 50-50 chance of doing it, regardless of starting out with 3.
Right.
So, but if I was to make another choice, say to the one in the centre there,
Yeah, you wouldn't choose this one, would you?
well, obviously not. You still got a 50-50 chance of being right.
Right,
That-
okay.
So I'll stay with my original choice.
Okay. Well, as it happens, you've won. So could you pass the voucher? Now, the question is, was John right to do what he did? Is it the right thing to do? Now, the history of this is that Monty Hall had this, and there's a lot of discussion about whether it was right, whether one should change or not in the circumstances. In about 1990, somebody wrote a letter to, there was a woman called Marilyn von Savant, seems a very unlikely name, who had a sort of column in Parade magazine, and people wrote in with problems to her, and she was I think she had the record holder for the IQ test or something. She was a highly intelligent woman. People wrote into her about problems they had, and somebody wrote in about this thing, and that's what the right thing to do was. And because there's been a lot of contention about it, and she wrote an article in Parade magazine arguing that the right thing to do was to change. And then she had, in response to this, she got a lot of letters from professional mathematicians, vitriolic letters saying how wrong she was.
Why was it the right thing to change?
Right, so I've got to try and convince you now that the right thing is to change. Obviously, John got it right. It's a probability thing. So let's just go. So let's suppose it's here again. Put that piece of paper under there to indicate that's it. And so the question is, it doesn't really matter. You make a choice. You choose this one as the likely, as where you think the car is, or the 50p voucher. and so there are 3 modes. So there's a probability of 1 in 3 that you're right. Now, of course, I know something that you don't, because I actually know where the real thing is. So there's a probability of 1 in 3 that you're right, and there's a probability of 2 in 3 that you're wrong. And if you're wrong, it's under one of these. Now, if it's under one of these, of course, you don't know which, but I do, and I show you this is not under this one. So there's then actually a probability of 2 out of 3 that it's under this one. If you want to perhaps convince yourself of this, imagine we had here 100 mugs.
Yeah.
I'll do a thought, make it 1,000. A million. No, let's stick it at 100, just 100 mugs. And there's a car or a 50p voucher under one of them. And you make a choice, and I turn over then 98 mugs, showing you they're empty. Now, in those circumstances, would you think it was right to change? And you might then, you still wouldn't, because it's then, you see, the point is, there's a probability of 1 in 100 that it's under each mug. So in that case, there's a probability of 99 out of 100 that you're wrong. If you make a choice, I then show you that if you're wrong, then it's not under any of these, so it has to be under this one. So there's then a probability of 99 out of 100 that it's under this one. That's all right, I don't need you to argue.
Sorry.
So I still haven't convinced you, right? I don't know what else to say. I can convince anyone. Anybody, you think?
Can I just say one thing?
Yes.
In mathematics, and you're dealing with probabilities, which is all fine, but as somebody who's really into physics, I'll stick with the experimental data.
Right.
And according to this one experiment, I was right.
Well, we only did one experiment. You can find on the web. There's a lot of stuff about this on the web. You actually can find experiments done on this, and you can do a sequence of trial experiments.
Darren Brown did one.
And you find that the answer, if you work out the probabilities, you do find that the probability of the person being right who's moved is 2 out of 3. The probability of not moving is 1 out of 3. The experimental data, if you do enough experiments, is that it should demonstrate that it's right to move. You can actually just consider. One way to do it is to consider all the possibilities, of where the thing might be and what your choice might be, and you consider all the possibilities, and you'll find that it is right to move. But it is counterintuitive, and I mean, one's belief is, given that it's empty here, one will think, well, there's a 50-50 chance it's under each of these, but there isn't, because there was a 1 in 3 chance under each of these, and there's still a 1 in 3 chance that you were. The fact that I provided this additional information doesn't change the 1 in 3 chance that you were right, and the 2 in 3 chance that you were wrong.
Well,
But if you're wrong, I'm saying if you're wrong, then it has to be under this one, because it's not under this one.
Yeah.
You didn't expect it to be doing this evening, did you?
Hey!
Right.